Now I just want to check to make sure that the reset still works. Hang on. Wait for it. Yay! It doesn't guru. Anyway, everyone, welcome my guest, Gigabates. Which way am I facing? That way.
Oh,
There he is. Hello, hello. Yeah. So, let me put some background music on very quietly because I've got this thing about I need just super quiet. I need some noise floor in my life. I don't know about you. Just music all the time, just running wherever I can. Right. Anyway, everyone, welcome Gigabates. Our guest this evening. Where do we start? I mean, let's do the boring thing first, right? So, let's go. Actually, it's quite well positioned because I have to look at that screen, which means it looks like I'm talking at you, which is quite cool. So, all right, let's do the boring thing first then. So, how did you get into computers? What was your first computer? What's your first experience with computers? And why, like the rest of us, is it so important?
okay. So first computer was Commodore 64. That, being sort of very young at the time, mainly just used it to play games, that kind of thing. Like most of us, eventually moved on to an Amiga, and back then didn't really do any kind of coding or anything like that on it. That was kind of beyond me back then, but watched demos and, kind of was aware of the scene and that kind of thing. So mainly using my Amiga again for sort of gaming and also doing graphics and titles for my skateboard videos that me and my friends used to make. So
oh, cool.
So I was doing, kind of graphics and stuff for that. So that was quite cool. And yeah, it was one of those people that kind of held on to the Amiga like long after it was dead and kind of persisted with that, not wanting to admit defeat and kind of, I think my first PC had kind of Windows 98 on it. So I was, hardcore holding on until the end of the Amiga's life.
Yeah, I think my first PC was my dad's Pentium 90 after he handed it down to me after buying something else. So it was slow as shit when I got it. So, so yeah. Cool. So that's yeah. I mean, it's one of those things that you when you're kind of entrenched in it. If you're not involved in the demo scene at that point, but you're still like, you're looking at it, from a distance, I guess. So and you're entrenched in it. So you've seen all the big demos and the rest of it. So
that's the thing. Like so stuff like. Nine Fingers and Jesus on Ease and all those kind of things, especially the kind of more music video-y kind of stuff that kind of you would just get passed around at school or whatever that everyone had. Was definitely aware of that stuff. So but didn't know how any of it was done. It was all a big mystery. So, and coming back to it, it was like, well, I wonder how they did all that stuff.
So when did you kind of get into that then? So, because obviously you must have discovered that like the scene was still kind of going and moving around and doing stuff. So
yeah, I think for like a couple of years before I actually kind of did anything, I was aware of just watching stuff from revision streams and seeing that this stuff is still happening. And then at some point I kind of stumbled across Photon's tutorials on learning Amiga hardware programming stuff. And had a little play with that, and so actually understand this stuff a bit more now. Actually understand how some of it works.
Yeah, it's amazing how like a career in IT or software development kind of gears you up for even if it's low level, it still gears you up for that stuff, right?
Yeah, exactly that. Right. So in the meantime, I'd got a career in sort of software engineering and understood a little bit more of the kind of principles behind all of it. And and just the fact that now everything is so accessible, there's so much information out there. If you want to learn about something, no matter how niche it is, it's all kind of out there. It's not like back then where it would be to either buy the right books or sort of word of mouth and that kind of stuff.
Yeah, or people selling their source code to their fantastic video compressor 242 or whatever it was, wasn't it? So cool. So so how did you and so I was having a look through. I think it's about 40 productions you've got listed against in demos here, which is so what year was it that you came back then? So it must have been, or not came back. Sorry, what year did you kind of dive in essentially?
So actually releasing stuff, it would have been 2023, I think. So I did the size coding tiny code Christmas thing, like the Christmas before that, and I think that was the thing. Like before that, I'd been doing little experiments and writing some code, kind of, not showing it to anyone. And if you're not part of a group, if you don't know any musicians or graphics people or anything like that, it's quite hard just to put something out there if you're just kind of doing stuff on your own. And the size coding thing was actually really good for that, because you can just make something, and it's kind of, by its nature, it's it's very limited in scope, and it's something you can just do yourself, and instantly get some feedback on it, and see it turned out people kind of liked some of the stuff I was doing. And then the first kind of actual releases were, and Love by It kind of following that there was people saying, oh, you should enter something after the tiny code Christmas things I did. So I did pretty well in that. Did the TIC80 stuff that I kind of started off there, because that was kind of the focus of that little kind of set of tutorials, and also did like an Amiga boot block for Love by It, sort of using some of the stuff I've been learning as well. And people kind of liked it. I ended up joining Desire. Raymond
Scouted
me as he does. Yeah. And then went to Revision following that. Released a little 4K. It's my first kind of non-tiny intro thing, and really went on from there.
So it's one of those, you start off with a small scope, and it just gradually gets larger and larger, and then you obviously when you end up in like a group like Desire, there's obviously there's one thing you can say about a group like Desire is that the management's pretty good, right?
Yeah. And there's plenty of people to work with, right? So kind of when I said like for Nova, I want to do something. Is there someone I can work with? Is there anyone who can do some graphics or something? Then immediately it's like, oh, I'm in a private channel with some people that Raymond's picked out for me who can help me out, and it's like,
bam,
sometimes it describes it like a kind of recruitment agency for seniors. So you can just get paired up with someone that you're going to work well with, and
That's kind of what I like about what Ryan does, is that he just kind of leaves you to it, right? He just like, let's just put the right people together and let them get on and do the thing, right? So what you wouldn't want in that situation is being forced to use certain assets, or being if you're doing something and it's your creative, you've got a vision about how it's going to look or what it's going to be like. However scrappy or well thought out that might be, you don't really want someone else kind of like enforcing anything on there. But also, you also want that as a melting pot with those other people, like how your graphic artist is going to have a view of how things are going to look, or how your palette's going to look, and you end up with that kind of bouncing around within that sphere of creativity and stuff. So and you probably have enough opinions already without I'm sure he has his opinions, but he kind of sits back and let a bit. So definitely. Cool. So here we go. We've got Inside the Machine on at the moment, which is quite. There we go. So if you look at the stream, you can see we've got a little reel of a bunch of things that our man Graham has worked on, which is that was a fantastic demo. Yes, obviously been burnt by the enforcement of deadline running off of a disc and other things, but let's not talk about that. we don't want to dredge that one out.
Here, is it? This is a recording.
It's a recording. Don't worry. There's all. Also, chat. You'll be pleased to know that I did download YT-DLP interface now. All right, so. I was downloading YouTube videos with some half-paid tool last week, and everyone was basically just badgering me in chat to go and get this bloody free application for downloading YouTube videos. I've done it now, and it's really good. Thank you, everyone. So I just spliced them all together. So that's that. So let's think. So in terms of demos, so we worked together on Vaporous. Actually, no, that wasn't the first time we worked together, was it? The first time we worked together was on the music disc, because you did the procedurally generated backgrounds for it.
Oh yeah. So that was a fun one. It was just like I just need some kind of I guess, size coding-esque routines to run in the background. So yeah, that was nice. Just
Yeah. Just it seemed like I was like, hang on. I was like, who do I know that does this kind of stuff? Likes this proc-gen stuff, this size coding stuff. That will not take up loads of disk space, but give us loads of image data. There's our man. So yeah, there was that, and then obviously we worked on Vaporous. Which, oh yeah, it's here. Hang on. There it is.
Oh yeah.
Yeah. So we've got the Meteorix for that. And then obviously we come on to revision this year. I don't think in terms of history, I don't think there's much more we need to pick about. We don't really, people want to know how you made the bloody demo. I mean, everyone thinks it's magic, so we'll kind of move on to that now anyway. So in terms of that, I think actually what I want to do, let me just show you this, because I found I came onto the project February, March time, I think it was, somewhere around then. I can't remember. Well, I didn't actually start producing anything until about 4 or 5 weeks before revision, something like that. I can't remember now. I can't remember what the timeline is. But obviously, what I saw from that point, basically the demo was already there anyway. But like post demo, I think this is the thing that I found really interesting. Let me see if I can pull this up without crashing or breaking anything. Bear with me a moment. Okay, let me go to here. Haha! There we go. Brilliant. So if we go to here. Now you sent me these pictures, which I found absolutely fascinating. And it's did you actually take these photos from somewhere? Or?
Yeah.
So this is so. I'll just show them, and I'll let you kind of explain what on earth. So what I love about this is anyway, I'll let you explain.
So yeah, I was going for a walk by the canal and just happened to see this random like destroyed organ with all of its innards kind of being reclaimed by nature. And thought, that's interesting. There may be something in that as a concept. So that kind of put the idea in my head of like kind of nature versus technology and that kind of thing. So yeah, so kind of that, and also I think the idea for doing a sort of falling leaf effect had come up before in another demo, and we ended up not doing it. So I kind of put those two things together.
It's like I've got an idea and I've got one effect. Now we just need to do everything else. Right?
Yeah, I haven't actually done the effects. I just thought a lot about it. So by the time it actually came to execute it, then it'd been kind of in my mind for a little while. So that was kind of the concept. And in the meantime, as usual, just kind of trying out different ideas. I had a few effects sort of, ready to use, and it was really sort of how do we put these into a narrative? How can we kind of hang these around this theme that we've sort of got half formed around it? So that's basically the idea.
Yeah, that's what I love. Just to see that, like after everything had been done and we'd released it and everything, and then you sent me this picture, and I was like. Oh fuck it! I see it. I can see it just like from that one bit, like how from that one idea, like because you can get that one idea and it implants itself, right? And it won't go away until you've fleshed it out and you've thought all about it and done the rest. And sometimes like they don't come to fruition. I mean, was it shipping forecast? I was thinking about that for about 3 years before I finally made it. So it's just one of those things. We have to say hello to Amiga Bill and all the raiders. I have to apologise. We're not particularly keeping up on chat today because we're having a chat with my pal Gigabates here, the coder of Second Nature. So anyway, we'll just say a quick hello. I don't have a way of you asking questions either, but what we'll do is when we've kind of finished kind of going over the stuff, we'll open the floor for questions then, and then. Oh, Zeron, mate, that's going to make noise. But thank you so much. Evil for admin. Doc K of Moods, Sigurd, and Peak Emma, and Proton of Finished Gold. Thank you very much. That is going to do that for the next few minutes. So yeah, anyway, moving on. So in terms of that, so obviously you had the idea in terms of what the theme would be, how that would kind of look, and obviously play with some of those effects. In terms of like the creative process after that, is that when, for example, Stefes gets involved, or
we had the channel still open from the previous demo from Inside the Machine, so just kind of chatting about ideas there, and I posted these photos and kind of talked a little bit about, maybe this is something we could do. So yeah, it kind of started off pretty slowly, but Stefes went away and did some kind of initial concepts around some of the ideas for the sort of leaves and some of the stuff that ended up being used. But yeah, at any time I would write a bit of code, come up with an idea for an effect, I'd share it there, and then we kind of bounce ideas off each other, and gradually it kind of came into some sort of shape that we could put it all together. So yeah,
cool.
And yeah, obviously initially it was just the team from Inside the Machine. We brought in Iridon as well, because I've been chatting to him and he really liked the idea, and had a lot of input into the concepts, and mocked up loads of different ideas. He's full of ideas.
He's never really short of those. I tell you what, he's great for that.
So yeah, that's about it really. So yeah, we just kind of gradually posted bits and pieces back and forth on the channel. Lots of ideas that never ended up being used, of course, that we could still come back to.
So you've even got little pockets of code of things that you've done that like you just haven't used yet.
Probably more in terms of concepts than code, or there are a couple of things.
Right. Oh, good. It's got a couple of things in the back pocket ready. Okay, for something else. Good. Right. Well, I'll tell you what we'll do. I quite fancy. I'm sure everyone else will appreciate this. Obviously, what I've. Oh, of course, it's disappeared. Hang on. No, there it is. It's all good. So I think what we do is we just go from end to end through the demo, and just kind of pick apart the scenes, because I know everyone thinks it's magic, and obviously it is, but it's obviously magic that is real and can happen. And as you know, with gigabates, obviously it does a lot of sharing. So I think virtually, at least is it only Inside the Machine you've done a full write-up for? I mean, that was probably the biggest thing you've worked on previous to this. That's
the one. So yeah, doing a write-up for this as well. So I've got a bunch of notes for that already that hopefully are going to help us as we go through it.
So let's just what we'll do, we'll just hit play, and then we'll just skip through. No volume. I don't want any volume. That's fine. Okay. So I mean, opening screen. I think everyone knows how this works, right?
Yeah, so obviously it's very much a graphic-based effect with great logo by Stefest. What else is going on with it? So a bit of palette flicker. I made like a Perlin noise table to do the kind of.
Well, I noticed that's really subtle on there, isn't it?
Yeah.
There was an earlier version where you made it like a neon blue, and then you switched it back out, and I was kind of glad actually.
Yeah, I don't think that was me. it was meant to more like illustrate the concept than be like literally make it these colours. So what are we doing? So it's basically the two palettes are more sort of changing the gamma curve than they are sort of just straight like lightening or darkening the palette. So
it's just really it's what I like about it. It's super subtle. Like if you blink, you'll miss it, right? But it's the devil's in that detail, isn't it? So. But you can just, if you look...
So it's got a gradient behind it that's done with my Gradient Blaster tool, sort of a web-based tool that I use to create these things, and the gradient sort of scrolls down at a slightly different speed to the graphics, so a bit of sort of parallax there. The graphics sort of fades to black as it's scrolling down as well, so it's sort of like it's silhouetted against the sun as the sky comes up. But
it just works. But actually, one of the first versions I saw this, there wasn't a top half of this image before. Did Stefes have to then draw that?
Initially. So I think Stephus originally wanted to do that, but wasn't sure if we had the disk space. And as you know, we've got loads of disk space, right?
Oh, we had loads. We had loads of disk space then, yeah.
So yeah, he went back and drew the kind of extended area of that, and yeah, it looks great.
Yeah, it looks really good. It just really nicely sets it off. It's just like, the movements all, there's probably some easing functions in there, right?
Yeah, that's the thing. So I've as part of this, I wrote a bunch of routines for like different easing curves. So the sort of the Robert Penner equations that we used to use back in the days of like Flash stuff. Got all of those as tables usable in this library that I put together. So, and using that with the scripting stuff that we did for the Neo Geo thing. So threads stuff, so you can sync stuff exactly to frames. So yeah, there's a bit there. I'm gonna have to write up as well.
I was about to say, like, I'm gonna have to pinch that, but I do have the code on my PC, so
yeah,
it's all there anyway. Now what? Right, so we're getting to the next one. Now, what I find, I had this conversation with so many people at Revision after it was shown, and I was like, honestly, this is, apart from obviously the MPEG failure there, this is probably one of the most impressive effects in the entire demo, right? I'd say probably, right? It has the wow factor, and we're showing it first. Right. What I love about that is like, why, what don't you want to save that for later? So no, for narrative purposes, this has to be here, and that's that, right?
Absolutely, yeah.
Absolutely.
So yeah, I mean, I suppose we could have used it for like end credits or something, but yeah, I wasn't really thinking in terms of like save the best effects for last or anything like that. Just trying to create some sort of narrative out of it, really.
Yeah, and I think that's that's the thing that I find like why not just having effects in a certain order because they're better or worse or whatever. It's that's not what it's about. It's about like the whole picture, isn't it? So.
Yeah.
Right. So you can explain this one now. Now you did explain this one to me, but I will let you explain. I know part of the blag, but I'll let you explain.
So let's do it then. So first of all, it's not just an animation. It's not pre-rendered. Like there is some element of any like doubting Thomases telling you that they've had a look in Oppenheimer. No, I'm joking. But like this, so there definitely are things being drawn in real time. But the big secret is that there's only actually 2 leaves. So what it's doing is every frame it's drawing a frame of the big leaf and the small leaf, and it's got a 16 frame, I think, cyclical buffer, and then all of the instances of those leaves are basically just a different frame offset from that buffer blitted into a regular planar screen. The texture, it's only 2-bit planes, so that means that the leaves can be on their own bit planes. You haven't got to clear them. They can do the kind of self-clearing thing as long as you've got enough padding around them.
Oh, I see. So you're just drawing over the top of them.
Exactly, yeah. So it just draws over the top of itself, and because it only moves like a maximum of sort of 2 pixels per frame, and it's got a fair bit of padding around it, if you get the sort of initial positions and speed and everything right, it will just clear itself, which took a bit of doing. There was always the odd pixel just left somewhere, and like
just when the leaf just gets into like the corner of somewhere, and then it moves across. And then this has been a bone of contention for him throughout the last 3 months. Is every version of the settings that he put them in, every now and then be like, no, it's left a pixel behind there. It's just
and where it goes wrong as well is if it drops a frame, then it's moved double the amount by the next one, and then it will leave a trail.
I see. All right, okay.
The sample loading, I think, could have potentially affected. But anyway, got it right eventually. So what that does mean is that the 2 layers, so your kind of big leaf and small leaf layers, they can't. Well, within each layer, they can't overlap vertically, right? So the big leaves can never be on the same line, or the same for the small ones. But there's a little bit of kind of variations, so they're not like exactly the same distance the whole time. There's a little bit of within that margin. They sort of move a little bit up and down with like a sine wave, I think.
Yeah. So you get these,
and
you
the
get like
horizontal
this
movement can do what it wants. So there's like some, again, like a noise table for a bit of random movement, and then a constant being added to it, so they kind of all drift in the same overall direction.
So they're kind of gradually all moving that way, but a little bit that way, but then that way, and then a little bit that way. Yeah, which is, it does a really good job of simulating that they're falling, but like the wind will generally be in one direction.
Yeah. And like the shading on it, so it kind of does a bit of a fake flat shading thing so for each of these 16 frames, we store the angle that it's like the kind of just the basic like cross product from the camera. So it chooses a palette based on that, and it's all just done using copper splits because they don't overlap. You can just set the palette for each leaf.
That's cool. So if we pause that there, for example, so the mouse. So you'd have like a copper split here for that plane, which would then change the palette for that one there. And if we hang on, apologies
so like between those two small leaves, there'll be a split that they look pretty similar, but they could potentially have a different palette.
All right. So these are they're only 3 colours each then.
Yeah.
Bloody hell.
But it kind of hides it. That's the thing with the shading, kind of hides that pretty well.
Yeah. That is amazing. Cool.
So, and like the actual texture mapping, I could talk about that, but it's a Blitter based chunky to planar self-modifying code for the kind of texture mapping loop. I'm sure I'll cover all of this in the write-up. What else? The text is on like the 5-bit plane in sort of it.
But using that kind of palette trick, right? But this is just,
it looks like it's transparent, just using the kind of combinations of those.
So when you put the 5-bit plane in, the color palette turns into an absolute nightmare, right?
Yep.
Absolutely. Got you. Yeah, and actually, you've got to deal with that for the leaves as well, right?
Yep.
Yeah.
So the leaves that go behind it? Like
because you can see here, like well, that's what I noticed about the ones that were behind. You can kind of, let's see if we can see it. Oh yeah, sorry. Come on, VLC, wake up. If we go to about here, come on, let's get some big text up. If we look here, you can actually see around there that
small,
you've got that like the diff. You can see that there's like a transparency to it, but obviously on these it's solid. So like for these, you'd have to set like that color palette in a bunch of different places, and for these you'd have to set that color palette, but also the differential color palette as if it was being seen through the text as well.
Yeah, all of that stuff.
Bloody hell. Yeah. Oh, well, this is why you do these things and I do the music, right? So cool. I think that wraps. Yeah, I think that wraps that one up pretty nicely. I think, unless there's anything else, I think that's pretty much it.
I think we've got a lot of other stuff to cover, haven't we? So
Let's try and not keep you here until midnight.
Oh no, don't worry about that. Don't keep everyone else here to midnight.
True. So actually, I haven't thought about this one that much. So I'm intrigued about this one.
So I can talk about this one. So it's the initial idea for it, I suppose, came from the Desire FM intro, where the last scene in that has got a kind of similar effect, where it's got radio waves kind of coming out from a logo.
Oh, can we just before we move on? I do have that here. Hang on a sec. Let me see if I can pull it up. Videos, YouTube rips, Desire FM.
So like the last screen when the music finishes, it ends on like a Desire logo with like an aerial or whatever.
Hang on, let me see. Let me go here. Hang on, let me just guess video. Is that's Desire FM? There we go.
Keep going. There you go. That thing.
Hang on. Right.
Yeah. So the Desire logo there. So it's got waves through that logo with a little sort of 2-pixel offset. Where it's masked. So yes, kind of similar idea, but the basic, like the the big trick on that is like, how do we just draw more circles? Because that only had like a couple of rings through it.
Yeah.
And only so many circles you can draw in real time per frame. So the big trick with this is it's kind of like the infinite bobs thing. So once again, it's got a cyclical buffer of I think 16 frames, and every time we've drawn 16 frames of one sort of ripple, then it adds another one on.
Oh, cool! So you're just basically doing one, and then the others kind of appear underneath it.
Going back to frame one and overlaying another frame on the outer sort of edge of it. So what that means is we can obviously draw lots of circles and create quite a complex mask.
Yeah.
So for each one we're drawing, you only have to draw half the mask 'cause it's symmetrical.
So you just flip the top and bottom? No?
So do another bit, like the modulo reversed. So,
I see. Yeah.
Creating like a 1-bit mask and then applying it once forwards and once in reverse to do basically just overlaying the sort of reflection image, but parts of it are nudged up 1 or 2 pixels.
I see. So you're copying the image with the mask, but offsetting it. Is that right?
Yeah. So the bit inside the mask is like offset by some amount, which decays over time. So it starts off like a couple of pixels, and then as the wave sort of decays, it's offset by 1 and then disappears. So yeah, that's kind of the idea. So it's another one where we're doing palette tricks with the transparency thing. So I believe there's 3-bit planes for the sort of reflection, and then 2-bit planes for the riverbed, like the rocks at the bottom. Mm-hmm. And they're being scrolled at a different speed, so you get that kind of parallax thing.
Yeah.
Only the top 3-bit planes are being masked, so the kind of ripple doesn't affect the bottom layer.
Yeah.
Which also makes it faster, of course.
And then I imagine the leaves are probably sprites then, right?
The leaves are sprites, and they're based on the image from the texture from the previous effect, but just kind of, manually created a bunch of frames of it. Can be doing that in real time as well. That'd be crazy.
So have you got some? Have you got some like a bit of a sine wave over one of those layers as well?
Yeah, that's right. So it's got a little sine wave on the top layer, just to give.
It's really subtle, isn't it? But it just, it really helps sell it, doesn't it? I tell you what, I was watching this the other day, and I was thinking, I thought you had some magical third layer of sky coming across the top, but it's not. It's just, I just checked it and went, no, it's not. That's fine. Yeah, there is still only 2 layers, right?
So yeah, that's pretty much that one. Again, it uses the sort of transitions library for getting the curve for the leaves falling right, and the syncing to the music. That's kind of important for this.
Totally. Yeah. I think you sent it to me, and the preview with when the leaf lands on that piano chord, and I just sent back chef's kiss. Just perfect. That's brilliant. Right. So cool. I mean, did you spot this bit? I mean, I God forbid I should do it here, but did you spot that bit up the top there? Just about there, I think it is. There it is. Well, let's see. Do you see that one? You'll not be able to unsee it now. There you go. There it is.
Well, the final version now.
No, we're done now. We're done. No, as I said to you the other day, I showed Gigabates the slight issue in Way Too Rude, where one of the bits of text gets cut off by this overlay effect that's on there, and I could not unsee it now, and I've showed it to him now, and now he could not unsee it now. He could, every time he watches that demo, he will notice a little bit of text cut out. Anyway.
So, the other somewhat interesting thing about that ripples effect is that the main sort of routine was coded in an airport coming back from 68k inside. I was in an early flight and coded up the bit with the rings and the buffer. I had the idea there. I was like, I'm going to go code it.
Excellent. Yeah, so, I imagine I'm like you, you're like me, where you book flights and make sure that there's plenty of time.
Yeah.
So,
Definitely.
and if you've got your laptop, you can have a little mooch around, can't you? So yeah.
Yeah.
Cool, nice. Right, on to the next one then. We'll just let it roll through. Let's see if I can get myself a little drink whilst we're here. Aha. So.
Yeah.
Right. So, I think I'm not going to make a guess because I think a lot of it feels fairly obvious in terms of how the Amiga hardware would work, right? But I think it's just that the implementation. I mean, the Sky I'm not sure of, but
Okay.
but everything else is like, okay, I get it. It's you can do a lot of this with the copper. In terms of where you display lines and stuff. But
so, you're pretty much there. So the bit with the Sky is also done with a copper. So it does the horizontal scaling scroll register trick.
Oh, right, okay. The was it World of Commodore where that? I think that's where I first saw that.
So it's obviously doing a bit of a sort of perspective, like the clouds are coming towards you, using that. So as it gets wider, it's revealing those columns.
So that's where you end up with that kind of. So actually,
exactly.
That's kind of, you would effectively, in terms of those scroll values you have to set, that you could pre-calculate that, right? And you don't need to change that afterwards, do you?
So the copper for that part is static. So that's just generated. I think I've got like some JavaScript that spits out that copper list. There's a whole bunch of like gotchas around like which columns you're allowed to skip without getting like blank pixels and stuff. So it's a bit of a faff to get it right. But so what that allows you to do is basically scale by like a 16th, basically. Like so per word you can skip 1 pixel.
Yeah.
And then once you've reached that threshold, you have to swap it for another image. So you still need some pre-scaled versions of it. So I think it's got maybe 5 versions of those clouds, like different sizes, and then.
I see. Yeah, like you can go out to like, you can go to 16 pixels additionally wide, and then after that you have to then flop it out. It's basically like a mip map, I guess, in a way.
Yeah, exactly like that.
Yeah.
So there's that, and then for the kind of vertical scaling, that kind of perspective, obviously that's pretty straightforward. It's just modulo, skipping lines with a copper.
Yeah.
The actual Sky, the kind of parallax aspects of that, there's 2 versions of the clouds. There's I think a 2-bit plane one and a 1-bit plane version.
Oh yeah, no, I see that now. Yeah. You can see it. You can see that there's one that's got 2 colours in it, and then the faster one that's kind of underneath it, the darker one, which is your grayer clouds. You can see that's moving a lot quicker underneath. Yeah. Oh, cool.
So there's that, and then the bottom half is basically the same, but with these ripples added. So it's got like a bit of a sine wave added to it, which that has to be updated like at runtime because it moves. So that's a bit of a pain because you've already got modulos for all of the perspective stuff.
Oh, Jesus Christ.
You've got to add onto those to add the ripple. So yeah, the ripple kind of adjusts those per frame based on a bunch of kind of predefined offsets, and we're just moving the offset in the sine table. What else?
I bet there were some instances where that looked like absolute trash.
Yeah. I mean, that's definitely the bit I put off for ages. I was like, the ripples didn't move for a very long time. So I didn't do that bit. Did eventually.
And the thing is, well, like it's so important for that scene to have that. And I mean, again, it's like the attention to detail is like it doesn't feel like what's the word I'm looking for? It doesn't feel like it doesn't feel like a sine wave from a 1989 demo, right? It feels like there's some like ebb and flow to it, which is obviously this is where the devil's in the detail. So that in that case, then, so is this whole screen essentially split down the middle then?
So yeah, there's two gradients, 2 sets of scaling offsets and stuff. And like the other bit we haven't talked about yet is the gradients. So that's actually probably the bit that's using all the CPU, right? So
I mean, it was, and then you put it down to 25 frames a second. So
well, only on the second one. This one is still 50.
Oh,
so
right. Oh, my Christ.
So we've done it now. We've proven we can do it at 50 hertz. We can do it.
Yeah. Okay.
So it's basically the gradients are calculated in real time. It's setting 8 colors per line for each line on that image. Well, apart from the black bit in the middle. So that's a lot of colors to lerp in real time.
Jesus.
So I think it's just over 1,200 of them that it's got to calculate, which is a lot. So how did I do that? So it's using a trick a little bit like how you do texture mapping, using the add X trick. So we've basically got the red, green and blue components spread across one long word and 2 words where the bits are kind of aligned so that you can recombine them into a single RGB value with, just a couple of operations with no shifts, basically.
Oh, nice. Nice.
So yeah, for each increment, it's doing 3 instructions, 16 cycles per step, and then another 16 cycles to recombine them into a single word. It's got some
that
dithering
thing where
there.
if you could add it, and then if it overflows, you can still set it to be the maximum value, isn't it? Yeah. I've seen that.
So the idea is like the integer part is in the next word, so you can then where it overflows, it will your add X will increment it in the next word of that group.
Right.
So like the fractional part of your blue is in one word, and then the integer part is in another word. So when it overflows, it keeps it where you want it without having to do any shifting, basically.
Right. Cool. I didn't realise that. Like, I thought that you might have. I mean, I know when we were doing the Neo Geo stuff, we just loaded the ROM with thousands of palettes because.
No space for that there.
Yeah, I mean, to be fair, the format of the Neo Geo color register is, I mean, it's not fun, is it?
No.
So you think the Amiga's difficult to do with shifts? Have a look at that. Jesus, it'll give you a headache. So yeah, that's fascinating. I honestly thought that they was just like, oh yeah, you've got
just an animation.
or just a bit of French real time, right?
Yeah.
But yeah,
so I suppose the other kind of interesting thing, it's doing dithering in the it rounds up on odd rows and rounds down on even rows, so you get that kind of sort of swapping where you've got the boundaries between those bands. That it's a little bit of vertical dithering there.
Oh yeah, so you can see that kind of these kind of gradient lines that you've got in here, can't you? So
yeah. So that's just done by having a different delta that we add on odd versus even lines.
Oh, I see. Right. So you end up with like around those boundaries, you get like a little bit of interplay, which then helps.
Yeah, exactly.
Oh, that's really clever. Oh, I like that. Wow. So yeah, all right. So that didn't work. I mean, they did. I had no idea how that worked. That's fantastic.
I think it's one of those that people don't really pay attention. There's a lot going on that, but it's because it's quite a sort of chill, relaxing effect. It's not one of the sort of, I don't know.
Yeah, I mean, it's like, I remember the when we were trying to do the disc loading with this, and you could literally, like, all the other parts, you'd hear the drive step to the next track go, yeah, that's fine, yeah, we got time, and then this came on, and then like
you'd hear, busy on this one. Yeah. No, that's
come on. Cool. I think that's wrapped that one up. I think. And is there anything else? No. Cool. Right. And where are we next?
So it's the tube lights bit here.
Oh, the tube lights. I know. I was really intrigued by this. Because this isn't just color cycling, is it?
It's not quite. No, there's a bit more to it than that. But it's still very clever palette trickery from Steph S for the most part.
Yeah.
So he kind of did this and did a prototype of it in JavaScript, as he quite often does, to show like where all the transitions and stuff should go.
That's kind of handy, isn't it?
Yeah, it is, isn't it? But basically, there's a range of colors for each of the lights. So there's a little bit of duplication in the palette that allows you to kind of fade each of those lights individually by just transitioning a range of colors. The thing that is a pain, though, is that big tube on the right-hand side with the kind of waves moving up and down it, that shares the palette with some of the other tubes. So we have to do like a horizontal copper split to stuff those colours in.
A horizontal copper split? Ugh.
Yeah, so we're waiting for a horizontal position once it's drawn. I think it's the first tube. It's sharing the same colours with that, and then switching the palette before it reaches that.
Oh, so it kind of gets to about here. The mouse, so it gets about here, and you're like, okay, we'll do.
All of those yellow colours in, yeah.
Oh, I see. So this one here, so kind of everything that's let's go back here a bit. Come on. So everything that's kind of here, because obviously that when that colour changes, that changes the colour of all those leaves around there. So you must be like around here or somewhere, and then you go. So these two are fine; they don't collide with that.
I think it's just the first one. I can't quite remember.
It's battle scars, right?
That first one and the yellow one on the right, we've got to switch a bunch of palette entries every line. So yeah, that's quite fun. And obviously the other part is the fireflies, which we've sort of borrowed from one of the later parts and done a sort of minimal version of it, which we'll probably talk a little bit more about that one when we get to the big version.
When we get to that one, we can also explain why it doesn't work on a Pi Storm. So
yeah, we can. It's not a real Amiga, that's why.
So now I was intrigued by this one. Is this just Steph Est with a fantastic amount of palette?
Yes. So it's kind of similar thing where you've got a different range for each of the kind of bands in that tunnel. But one thing that is interesting about this is he used EHB, extra half bright mode for it. So somehow managed to make use of that to fit some more colours in.
Bloody hell, I don't think I've ever heard of anyone actually using it other than doing a sixth plane that creates darkness, right? But that's actually using the EHB to do basically just like it's a 64 colour image with colour cycling on it.
Yeah,
which in itself is bonkers. Bloody hell, that is okay. I had no idea about that. Wow, that's. I mean, yeah, it's also it's just like, and also when you flash that up there at the end, very nice, very nice. Right, okay. I mean, I don't want to kind of downplay how complicated that is. Right?
I'm sure figuring out those palettes was an absolute nightmare, but yeah.
But yeah, that's his job, right?
Yeah.
Yeah.
What's that, sorry?
That's his job, though, right?
Of course, yeah.
Yeah.
And it's another one where he made a prototype of it, so it's pretty easy just to translate it all from JavaScript into assembly, as easy as those things
As easy as those things are, yeah. I mean, yes and no, yeah. So I suppose just for context for people watching, if you want an example of Steph Est and how he can manipulate color palettes at this kind of low end of technology, go and hunt out his color cycling picture from GURP, where he did a video about how that whole thing was made. And his own, he's got, was it dpaint.js, I think it's called?
That's the one.
Yeah, where he's implemented, it's this weird kind of combination of like old school graphics tools with this sensibility of like modern tooling on top of it. But anyway, just when you say this is a extra half bright image, I could understand how he's managed to do it. It's just I don't know how you would do that. But I don't do graphics, so just.
So yeah, pretty much at GURP we had a look at that AGA one he did and just said, can we just have some of that for the demo? You can do it on OCS as well, right? So yeah, you can.
Excellent. So that's what you were doing all Saturday afternoon then? Like, come on, mate. It's just... Yeah. Excellent. Cool. I mean, yeah, hats off to him. Right, here we go.
Yeah.
Right. How?
How?
Right. So now before we get too deep into it, now what I did notice is that you've got I can see there are some computational savings, right? In terms of the outer edges here, and there, obviously.
Not so much computational savings on those ones, actually.
Oh,
the dithering is more just for effect.
Oh, okay.
There are other things. So on that, like the blurring towards the edges is meant to be sort of depth of field sort of approximation. It's just scrambling the pixels into a kind of Bayer dither. And that's really just to hide the big blocky texels and make it look a little bit more...
Oh, okay, cool. So rather than...
they get quite visible as it gets really close to the camera.
Yeah.
But yeah, the big computational saving is that it's mirrored vertically, and we do everything we can to hide it. It's probably still very obvious.
Okay, so actually, really, like 90% of the texture mapping that's going on is there.
Yep.
And you're copying that basically to there, apart from in this spot here.
No, it's copied there as well. That's a sprite.
Oh my god! So you're actually rendering like the whole tube underneath?
It's just reversing the modulo, right? So it's just mirroring the screen.
Oh, I see.
And then you don't see the lights on the floor because we've covered it up with a sprite. It's as simple as that.
Okay, so it is actually only... Oh, that's really smart. Why didn't I think of that? Of course, yeah. You're actually only rendering the top half of this, aren't you?
Yeah, and like changing the palette as well, so all of the kind of orangey colours fade out, and then the bottom half doesn't look the same because it's got its own palette.
Yeah. I mean, that is it. Bloody hell, that's so clever. I thought you were just like, we just won't render that bit in the middle, but no, actually, yeah. When you look at it now, yeah, it really makes sense. Yeah, you only have to render that half, and then obviously, if your lights are only spilling over into this area here.
Well, they do spill over a little bit more, but just by changing the palette, you can kind of hide it.
You can kind of hide that anyway.
Grey. Yeah.
Shit, right.
That's part of it.
That is brilliant. Why didn't I think of that? Oh, God. Yeah, so that's just a big sprite there.
Yeah. And obviously, like, there's a bit of a copper bar thing going on, which is meant to be sort of the lights shining down onto the floor a little bit.
Okay, yeah.
Just so it's not completely black, just to give a little bit of movement to it.
Yeah.
But yeah, in general, it's just a table effect. Say just a table effect, but like it's probably the somewhat novel part of it is that it's a 1x1 4-bit plane, chunky to planar, which I hadn't done before.
I mean, we've seen a lot of like chunky effects and the rest of it, but I mean, this is not chunky.
Yeah,
right.
Actual pixels, yeah. And the problem with that is it's more drawing the pixels. It's just the sheer number of pixels you have to move per frame. Like the chunky to planar bit doing with the blitter, that runs in parallel. That finishes a lot quicker than the draw routine.
So so basically you'll do like a line of it, and then you'll tell the blitter C to P to kick off and do that line.
No, not even that. We're just drawing the next frame. So the CPU is drawing the next frame in chunky format. Basically, each pixel is a word in like a particular sort of scrambled set of bits. So it's filling up the buffer for the next frame while the copper is transforming the current one into planar. So yeah, you get using the blitter that way. You've got nice bit of sort of parallelism going on. You can pipeline those two things.
Okay, so in terms of the C to P then, so it's purely blitter driven. So is there like a bunch of passes that has to do?
Yes. Well, I might have written down like exactly what they are. Probably not too much to get into, but like yeah. So yeah, it's basically merging together two words to get to kind of combine the bits. So the the trick to it is that the format we're writing the pixels has duplicated bits. It's got repeated bits. So even though it's it's a 4-bit value, it's got those bits kind of repeated out, and then you can merge multiple pixels together just using masking with the blitter.
Oh, okay.
And then you've got to do a swap in groups of 4 bits, and then another swap in groups of 8 bits to end up with each word has only one bit number in it, if you like. So we've got a word of just bit 4 and another word of just bit 3. Anyway, it's probably one of those where if I write it out,
you've worked out how to do it, and it'll be in the write up. yeah. Cool. But yeah, I didn't think about the sprite. I should have put this into what I haven't done. Actually, the only thing I've done is put this into Copenhagen and looked at the track loader and the sample streamer. I haven't actually looked at any of the demo stuff, but yeah, I had other stuff to focus on, right? You had other stuff to focus on, so cool. That's that's smart. I love that. I love that effect even more now, because it's like, because what I thought was like your saving grace of like over here. No, you're just basically doing this as a DOF effect, right? And just to kind of smooth it out, so it doesn't look like 90s Doom, right?
Exactly.
Yeah. And then I understood this bit in the middle here. It's like, oh yeah, because you don't have to. Yeah. Anyway.
Just infinite distance just becomes a big jumble of pixels when it gets
it just doesn't look good, does it? So it's they're done for aesthetic reasons. Now the thing that stole all of our actually, before we get into this, I think we should probably just let's give ourselves a little 5-minute break, yeah.
Sure.
Yeah, and get everyone else to have a little break, because I mean I could do with another drink anyway. So we're gonna do some Imploder, and then we'll be back in about 5 minutes. That's it. Yeah, all good. Cool. Right. Well, we'll do a quick BRB, and then we'll be back, and then we'll just carry on just running through this, because I've got more questions. So right. See you all in a bit. Hello, welcome back everyone. I've got my good friend Gigabates here. We are currently trawling through this demo. Why is that not making any sound at all? Oh, it's very quiet. Okay, that's fine. Doesn't matter. Okay, let me just... Where were we? Okay, so we're on to the infinite zoomer. The I think this is probably the effect that's caused both of us the most pain, I think, in terms of disk space, disk space and reliability. So yeah, I'm intrigued. What chat won't know, because I mean I know, because I saw the earlier versions of it. This outer section here, see where the darkness is. There's actually a full color image that's there that also zooms, but because we ran out of disk space, we made it black, right?
Yeah, it's still 2-bit planes, so it just they all happen to be black.
So what I find funny is that we're scaling. We're scaling that.
Unnecessarily blissing more than it needs to.
I know, yeah, we're scaling it, and it's like it's doing nothing. It's just all it's doing is covering up the image. Which is mad. Anyway, Graham, please enlighten us into how. I mean, I get an idea. This is like, it's basically kind of 2 or 3 layers of zoom that we end up with. But how
does it work? So each layer basically starts off at 50% scale, and then scales up to 100, which is. Like the original image for each layer is double the size of the screen, so like 640 by 360. Although we don't actually include all of the data from that, because, well,
it's a waste. You're including pixels that you're just never going to draw, right?
Exactly. Yeah, that's quite right. So what it does, the vertical scaling, you can probably imagine is very simple, because you've got the copper, you can just skip rows. So the image just starts off skipping every other row at 50% height, and then one by one sets the modulo to reveal each row as it's sort of distributed across the image to make it look kind of natural scaling.
Yeah.
The horizontal part of it, not so simple. So that so that starts off with a kind of 50% size image in one buffer, and then all of the kind of missing columns in another buffer. And one by one, it will shift the image to like away from the center to make space, to make a one column gap, and then blitz one of those additional columns into that space. So it's kind of it's inserting columns into the image, and that's done. So it calculates offline like what order to insert the columns, because it's a bit of a tricky one, because it's not like when you do kind of regular nearest neighbor scaling that columns can kind of appear and then disappear again. Once a column's there, it stays there. Right? And you need it to kind of look natural, like the distribution of those columns being inserted, and to keep the proportions of the image, etc. So that's all kind of done to generate a list of operations per frame. So, for a given frame, it will be reveal this row in the copper, insert these two column indexes into these two positions, whatever. So the other thing that's a real pain, though, is you need to do everything twice because it's double buffered. So the columns you just inserted on the other buffer, you've got to do again on this one. Otherwise, they'll be out of sync. So you've got to do twice the amount of work to keep those.
Right.
Which is a faff. Yeah.
Yeah.
So that's basically it. And then when it reaches 100%, you've got to swap it out for another image. The thing that makes that a pain is we haven't got space in memory for all of the images, so they need to be loaded off disk and swapped at the correct moment, not too early or too late. Otherwise, you end up with various glitches. So and we kind of glossed over on the first level. It's got dual play fields, so you've got what was 2-bit planes for the foreground and 3 for the background, and then all of the other ones are 4-bit planes, just a regular single image.
Okay, so this start part here that's dual play field with this. So you're effectively, the zoomer can effectively operate on 4-bit planes.
So it'll work on any number of bit planes, but you're limited by the speed, right? Because the more bit planes you have, the slower the blitz are going to be, the fewer columns you can insert per frame, and the slower it's going to zoom in. So, if you wanted a very fast zoom, you'd have to reduce the number of bit planes even further.
Okay.
And that's why the lights are off on this stage, right? It's just a blue palette because you've got half the palette size. So even though that looks like it's kind of part of the design that the lights turn on, it's also very convenient that you haven't got the palette to do it on the first level either.
It's what I find really funny as well is actually this outer section. You could probably distill that down now to a single bit plane of just and
then that could have been 4-bit planes. You could
have just put that as like say like a quick plot and a fill, couldn't you?
Annoyingly I just didn't want to touch anything at that point. You're right, we could have because of the reason we changed the foreground to be just a single color is just because of this space. Like these images are huge, and that was just, and also like Iridon did have the feedback that actually as you're coming out of the tunnel it would be very dark, we maybe needed to fade in from black at least, because your eyes are adjusting and yada yada. So it actually looks good anyway. I think it was.
There was an earlier version, obviously before we ran out of disk space, where you did start it black and then you did a palette fade as you came out of it, and it looked really cool, but we couldn't fit it.
I mean, I'm sure we could have given more effort and fight hunting or whatever, but
dead lines.
The reason I wasn't that bothered because I think it does look good as it is. So,
totally. All right, so that's interesting. So yeah, so as soon as you see one column of graphic appear, that's it. I suppose that's what gives it its I don't want to use that word, but it gives it that. If it was like a properly full scaled image, like every pixel was scaled, like you'd obviously get a different effect, but you're not going to get away with that on an Amiga, right? Not on a 500 anyway.
Ideal. Put it that way, yeah. It's not how you would want it to look if you could do it.
Yeah. I mean, if you could do every single pixel, that'd be great. But like there's that balance of we'll the Y we're flexible, we can do what we want. But the X is where there's going to be some. But even if we just pause it, I mean, as individual images, they still look great. So. Actually, have we got before we move off this one, there was a full colour image of this, wasn't there? Where's the
Yeah, I don't have that to hand, but yeah, I'm sure we can post it on the write up. There's
let's post it on the write up. Yeah.
Big high res image of the entire thing, all of the levels in one.
It's like it's huge compared to like what. Yeah, I did see it, and it is gorgeous. It's really lovely. Here we go. Right, so Fireflies. Now I know this one. I know this one well because for Secanoid, as I was developing it on stream, we watched Absolute Inebriation by Virtual Dreams, I think it was. That demo, and I was we were watching that demo on stream and I went, oh, that's got a lot more particles than I have, a lot more dots than I have. And then Emun disassembled it, and then built basically the particle engine for Secanoid from that disassembly, and made it faster as well, but because as he does.
So yeah, you're right, it's the same thing. So let me just grab my notes, but basically, we've got the coordinates of each of the particles as fixed point, and then the blitter goes and converts all of those positions into instructions, into just a B set instruction to draw an individual dot that you then go and execute. And if you're on a PyStorm and it gets cached, it doesn't draw anything. So yeah, that's the main thing, right? Is that you're storing fixed point coordinates and transforming them directly into code, which you can execute. So I think it's 1024 dots currently.
Oh, you went for the maximum blit size then, right?
That's exactly why. Yeah. So the maximum height of a blit on OCS is 1024, and you're doing like a 1 word width blit to do that transformation. Probably could have done more, could have done multiple blits, but to be honest, I think that's enough dots.
Yeah, it's enough. So my question is then how do you do the flickering then?
Yeah, so it's actually. So you mean just in terms of the colours as they're moving across the? It's very simple. It's an XOR on top of the image. It's just flipping bits, and then the way it clears them is it flips them back again. It just runs the same code to XOR them back again.
Oh, okay. So you run the.
So yeah, in fact, it's not a B set. It's a bit change, right? So you're flipping them, and then you're flipping them back again. So all it's basically doing is it's swapping the pixels from the bottom half of the palette to the top half, and vice versa. Which, if you order it nicely, makes it kind of look like,
Okay, so you're basically going, you're kind of poking a hole, and then unpoking that hole back to restore it again. Oh, that's really clever. I like that. Cool. I think the way.
It's really satisfying that the clear routine is just run the same code again.
Very nice. I think the way the way it works on Secanoid is that we do obviously. I mean, it's the same process. Obviously, you've got 2 arrays of X and Y, and then you use the blitter to basically. I think it's 2 passes we had to do it in to set. Because you've got basically the offset, there's the 8-bit offset and the address offset that you have to set. So there's 2 passes on that, and then I added a third path that would take a random position in a random table, so like a table of random numbers. It'd take a random position of that and then say, right, well, we've got, 200 that we're going to do, and then it would apply that to the address and then shift the address either to like one plane or the other. So,
right.
So you do like because in that situation we're drawing onto that, then we're clearing both planes every time. Because we've got all sorts of other stuff going on. So you want to draw and then clear and then draw and then clear. But yeah, there's like a third pass that then would just it would just change the register to A0 or A1 depending on which plane it would write to. So it would just do it like an additional pass. Go there we go, and that's how you get like the flickering there. But XORing that's. I like that. That's much nicer, particularly on like this kind of color image. That works really well. So
yeah, I'm surprised how good it looks. It does look better than just all being like white pixels or whatever. Right? Which
yeah, definitely.
And we were a little bit like, well, how are we going to do this? We've got no bit planes left, and then it was, oh, well, this looks even better. So yeah, pretty pleased with that. So as far as like the actual movement of the particles, I can talk a little bit about that.
Yeah.
So as well as the position for each particle, we've got a delta, or basically a velocity that you're adding to that coordinate on every frame. And then for a certain number of particles on each frame, you'll recalculate that delta. So the kind of trick is you don't have to recalculate the velocity of every single particle. You can just do like 16 of them or whatever per frame, and eventually they'll still kind of, move in a kind of natural formation. So you're
doing like blocks of them like that.
Yeah, exactly.
Because that's the stuff that's computationally heavy,
on every
right?
particle, but recalculating it on just a small number of them on every frame.
Right, because that's the stuff that's like that's you don't want to do that for all 1024 of them, because anything you do as soon as the count gets above 100, like it's a problem, right?
Yeah. So the recalculation, I've got here what it does. So it basically adds some decay to the current velocity, so slows it down a bit, adds some random value to it, and adds some bias towards like an attraction point where you want them to sort of swarm around. So yeah, it just combines those into a new value.
But then you just like chunk that out. Like, okay, this frame will do these 16, and then the 16, and the 16, and okay, and then you end up with that kind of, the kind of following behind each other anyway. So
yeah, and because they're all random anyway, like it doesn't matter if you just do them in order. Like it makes no difference. So you can just do the first 16, the next 16, whatever. I can't remember how many it is, but yeah.
But it lends itself into that kind of swarming effect. Like it's like free reality at that point, right?
And then you can move that attraction point as well. That's what we do on the tube lights earlier on, and that's why it moves from one side of the screen to the other here. Is that you can just change that, and then eventually they all kind of catch up and move towards the new center.
Oh, nice. Cool. I think that's that one, isn't it?
Yeah.
Let's
move on.
Now this one's we class this as a Steffe special, right?
Yeah.
When it comes up.
Yeah. So this one was another one where I'd kind of said to Steffe, let's just have a few kind of simple image-based screens for when we're loading and unpacking some of the bigger, more complex parts. And all of the kind of color palette and copper tricks that go with that. So this was meant to have been like a really simple one, but actually when you look at it, having like sort of copper bars moving independently in two different directions is a real pain to do. Because what you've got to do is either update every single color on every single line, which I didn't want to do, or calculate where each of the palette changes is and then sort them by Y position before you write them into the copper list.
Okay.
So it calculates where each of the palette changes is, and it does a radix sort on them. It works them as like a data structure, does a radix sort, and then writes them to the copper.
Okay. So basically, you're saying there's like, I don't know, these are the ones that are going down. They're 5, 8, 10, 12, whatever, and they've got the ones going up that are, you know, at these positions. Throw them into a radix, sort them into 0 to 256 or however many it is, and then write out the copper list afterwards.
Yep, that's what I'm doing.
Cool. Alright, so you're just basically, I mean, that seems like a simpler way of doing it than, I imagine you're probably writing a bit more for your copper list, so that, because it's not like, you're not just like, we're just poking the resulting color values. What you're doing is actually actually there's going to be a trade-off with that, isn't there? Because
I mean, I think the alternative would have been to have way more entries in the copper list, because if you wanted to just be able to write them directly in on that line, you have to have every color set on every line.
Yeah, and also
then
it'd have to be quite,
that frame.
The format would have to be quite rigid as well, wouldn't it? Because you, if you want to do, like, maybe you could get away with doing some blitz into that, right? But then if it's not a a standard width structure, then you're not going to be able to do that, are you?
So it looks good. So yeah,
if it looks good, yeah. I love the site. It's like this should be simple enough. It's like, no, it's not.
I mean, it is good. It's not that bad. It's just it's more complicated than I thought at first glance.
To be fair, I still get nightmares about the copper list from the floppy disk section from Circumvent. So yeah.
That one.
Yeah. I just, look, for anyone that's not a coder, but the copper's amazing, but it's also a pain in the backside, right? And also line 100. Yeah. Truck. It's real. It's a pain. Yeah. Line 100. There's no way around it. Well, there is. I mean, there's a way around it, but also the other way around it is to waste loads of DMA time. But anyway, let's not get into that. So yeah, the simple one, but then okay. The money shot, I guess, is the sphere map. Now, what I found really funny was it Steffes that did it when we were at revision? We just sat there, and then you showed me that he'd done an entire sphere map of revision. Oh,
I did it.
You did it.
My phone has got like a panoramic mode on it. I just stood in the middle of the hall and then generated a new image. Yeah, that was fun. But yeah, maybe we'll use that for something.
We'll use that for something. Don't worry, it's in the bank. So I imagine this is a combination of obviously your. We won't go into the details of the Blitter C2P stuff, but I imagine it's kind of a bit of that and some clever maths.
So yeah, absolutely. It's another C2P. It's a different one to the one we talked about before. It's a Ham 7 based one.
Ooh.
So yeah, it's all true color texture, and it's a sort of 2x2 resolution, although not quite, because you can only set 2 RGB components in that size. So what it really does is every other pixel or sort of texel omits one of those components, but it looks good enough. So it's the one I used on Beacon of Hope for the texture mapped polyhedron thing. So I've already done a little write up on that if anyone's interested. But yeah, I mean, really, on the Amiga side, it's not that complicated. Well, it's another table effect. The complicated part is how you make a sphere map into just a simple table, because normally it isn't. Normally each line has like a different view angle and has to be calculated in real time. So and also, if we didn't do anything clever with it, you'd need a huge texture, because of the way that the texture is kind of distorted. You've got lots of wastage in the kind of extremities, the top and bottom of your sphere map image. So what it does is it slices it and then scales it accordingly to like the smallest we can get away with for each sort of strip to
Oh,
make it
okay.
fit. So yeah, and like generating the image, there's a nice sort of panoramic editor in Affinity, which we found out. So you can go in and you can, in your image editor, you can sort of view it like this, and you can go and paint over it, which is very cool. So yeah, I think generating the data was a challenging one on it, more than the Amiga side. It's all stuff we kind of done before on the Amiga.
Yeah.
But it was, how do we actually generate this as something that can be rendered?
It's like the implementation's different, but like the groundwork in terms of how you get those pixels on screens, it's already there. You've got it all right.
Yeah. That's right.
Wow. And do you want to let anyone know about the secret part here?
Yeah, why not? You can right click and you've got manual control over it. You can move your mouse around.
Yeah. So it's to prove it's not. Was it French real time? Is the phrase, isn't it?
Yeah, it is real.
It is real. You can if you run it. I mean, I don't. Did you manage to employ the clamping, or can you still crash it here?
I think it is clamped now. Yeah.
All right. Good.
Yeah. but like really, I put that in because I was using it for the scripting. I was trying to find like the sort of keyframes where I wanted it to pause and figure it out, and then I just left it in. So yeah, the movement is all done using splines. So what I've got is just a bunch of sort of pan positions with a timestamp on them, and it will sort of make some nice curves to sort of move through that path. Yeah.
I do remember that when we were working on this, he said, "Have you tried the right mouse button?" And then I instantly crashed it. I was like, "Oh, maybe I should add some clamping to that." Okay, but yeah. So I can imagine, like, when you're working out what you want to look at, because I imagine you could just spit out some debug values at the bottom or on the output. So you're looking at this height, this position, or whatever, this XY on the sphere, and go, okay. So in terms of how we want to physically look at this when we're in the demo at this particular point, because I mean this is also like, there's a really nice touch here when you see here when you kind of that transition into that screen. It kind of, it feels right. So it kind of spins around and goes up to there and goes boop, and then that screen instantly appears. So
yeah, no, it took a little while to get that right with movement, but you're right.
Totally, yeah.
Basically, move it, open up the debugger and view what those offsets are, and put them into the script.
Yeah.
For each kind of position.
Cool.
So
So there you go. That's how that works. That's just a plasma, right?
Just the plasma. Yeah, I mean it kind of is. So it's a similar kind of chunky mode. It's another ham one. The thing that's kind of interesting about it is that for every other line we swap the red and blue components.
Okay. So that gives it its scan line effect.
Yeah, and also for every other line there's a delay on it. So I can't remember how many frames, but like the odd lines are X number of frames behind the even one.
Oh, okay. So it kind of reduces your calculation requirement down by half.
Well, it was already double line height, but it's a sort of motion blur. And the thing, because of the color split, it's like as those two frames diverge, you get a sort of almost like a holographic kind of split where those colors sort of don't align. Anyway, you can kind of see what it does.
Yeah. And I mean, in terms of the outer, obviously, this is very important here. I'm very proud.
It's all very cool.
I'm very proud of Stefes doing us a little TTE TV. It's very nice. And also, just in terms of like the creative process, you have to remember that sometimes you do stuff and it doesn't work first time. And Stefes did an initial sketch of this scene. And dropped it to us, and we're like, "Oh, that's kind of cool, man." And he went, "No, I'm not happy with it." And then he threw it away, right? So I think it's really important in terms of the creative process to understand that sometimes you will make stuff and you will think you're proud of it, but maybe you just need to just throw it away sometimes, right? Sometimes you just need to it's not working, get rid of it. But yeah, this is I'm very pleased with this. Unfortunately, everyone on my stream suddenly said, "Why does that not say channel 5 in reference to the 5th channel of Imploder?" But you know,
I don't think Steph knew about that.
I know it was a missed opportunity. I was too busy telling him about the history of Channel 4 in the UK at the time. But there we go. So
yeah.
Oh, hang on. Oh no! What's happened?
Uh-oh.
Hang on, it's all right. No, don't worry, I can fix this. Look, there we go. Look, wait for it. Yes. Okay. We need to pull that back into there. There we go. I know what I'm doing. I'm a professional. Right. Okay. So we're nearly in the demo, aren't we? Here we go.
Yeah.
Oh yeah, there we go.
So yeah, I suppose the kind of idea behind these two effects was, well, obviously to incorporate it with the CRTs in the previous scene, but also like how can we present an effect that can't be full screen in a way that still makes it look quite cool. So you've got the kind of top and bottom part of just bitmaps, and then the borders of the screens are sprites.
Yeah.
So yeah, it's a kind of creative way to present it without it being obvious that, hey, this is kind of a pretty tiny screen area.
Yeah, I like that as well, because he's like the bezels they just work, right? And what I like about the second one is the you employed the if it's quite, you might miss it because you're focusing on this bit, but if you look at the bezel around the edge, you'll see that it's like there's some like, it feels like it's reacting to the contents on the screen. I mean, I'm sure it's not.
Not quite, but they are colours picked from the image. So
yeah. But yeah, it gives that impression though. So you just like sampling like a corner of it and going, yeah, okay, that will determine which.
Just pick a few colours and make a gradient from them, and then it just sort of cycles through that, I think. Yeah. And yeah, the roto zoomer it's using the same kind of screen mode. It's got like this sort of rubber effect where you add constant to the offset on every line, and then we can kind of sync that with the music as well, where like the scale factor and the distortion factor and all those sort of things can be set on a keyframe. So that's how it kind of adds a bit of sync to it.
I think also, like, in terms of thematically, it worked quite well here as well, because it's like you get all the CRTs, they're all on, and then because it was kind of the other way around before, but then you switched it, because then you have the plasma, which feels like that's more technology, and then you have the flowers kind of trying to break out of the screen at this point. I don't know if that's like if that was a conscious decision or whether it's just like that works better.
There was a reason behind it. I don't know if that was quite it. I can't remember. We can post-rationalise it however we want, I suppose. But no, I think it just works better that way around, doesn't it?
Yeah. Because then you're kind of returning back to nature at this point. I mean, this is basically again. It's kind of a repeat, but there is difference to this. That's what I like about it. Is like, it's not we're just showing the same effect again here. Like the scene is slightly different. Actually, that's interesting in itself, because the entire scene previously was flipped, but you've actually got an overlay this time. Yeah,
that's interesting, isn't it? So yeah, for the foreground part of it, it doesn't mirror, it doesn't change the modulo. It is just a somewhat symmetrical image. Which kind of worked. So the thing that we had to be kind of careful about was the fact that the tree in the foreground is actually affected by the water ripples. So if it wasn't for the fact that it only kind of overlaps with the sort of tree trunk area, which is quite a straight line, it would look really weird if you had leaves and stuff in the foreground that were wobbling as if they were in the water. So I had to be kind of careful just picking composition there, so it's not obvious that's what's happening, because it really is like.
Oh, yeah, no, I can see it now. I can see it just like about there. You can see it ripple, can't you?
Yeah.
Oh, wow. Oh, I see. So, okay. Wow.
So yeah, and originally this part was not. It was a sort of 24-hour cycle. Like before we had the kind of structure to the demo of this sort of day and night thing. It was basically going from night to day and back again. So then we had all of the color palettes for both the sunset and the sunrise. So I still wanted to kind of keep that, and it made sense, yeah, just to put it back in.
What's this written? I'm ignoring that, Thalamus. Was this written in Amos?
I mean, no.
No.
You want to have a go? I guess. Yeah.
Alright, so actually now we're getting on to like some of the most. No, I think I said this to you before already, but you can. I really felt it during the competition when this was on live. I got a real sense of it felt like a bunch of kids when they were watching it. The reaction felt like a bunch of kids at a fireworks display. I think that's the best. That's the best way I could describe it, because there was a lot of like other demos when they're like quite boombastic. You're like, yeah. And this was like more like ooh. Like, and like the next two sections of the demo really did like to create that. I don't know. It's just that I guess that ethereal kind of emphasis on it. But yeah, this one was very lovely. How the hell does that work?
So yeah, it's basically a little bit like the leaves effect in that you've got two much smaller chunky effects being blitted into a bigger image.
Oh, okay.
So each of those water droplets is being drawn on a much smaller sort of chunky canvas, being run through C to P and then being blitted on top of the background. And also similar in the way that they're self-clearing, that we have a bit of border around them, so they kind of restore the background in the bits that aren't distorted. So yeah, I think the hard bit on this, well, one of the hard bits, was again getting the data. Like, how do we get some realistic refraction and, you know, the kind of glossiness, the sort of tonal overlay on it, which doesn't look fake. So the shape of the droplets is changing as they're rolling over the leaf. We've got, you know, multiple frames of sort of different variants of them that it cycles through. So yeah, that was all done by me in Blender. So really did like create a sort of a 3D sort of glass-like sphere with a bit of noise-based animated distortion on it, and then rendered out sort of a series of frames of, first of all, the kind of lighting of it. So just rendering that against a grey background, and then creating some sort of bobs out of it, and then creating the tables by sampling the sort of UV offset from the distorted part of it, and building it.
So that kind of works. So you'd say like, say it was on you put that. You've got different frames or different shapes of droplets, right? But you said let's just take, let's say, frame 1, and we put it on a UV map or a square of that. And then you put that on there, and then you go, right, well, I'll sample that, and then the result of this pixel here would actually be bent round into that pixel there. And
exactly, yeah.
Cool.
So, and there's like 3-bit planes of that. So the background image and the kind of distorted part of it is 3-bit planes, and then there's another, I think it's 2-bit planes of the sort of tonal variants of it that just kind of shifts the palette to add a bit of sort of a gloss to it.
Oh, okay. So like to get the difference in colour for those pixels, you've got an extra couple of planes that you can kind of kind of dig into, so to speak.
Yeah, so they're just kind of regular bobs like over the top of it.
Oh, okay, yeah. I see, yeah. Very clever. Look at that. Smart. Cool. And then, now this is one of the greatest reactions actually, because at first, I've been watching. Obviously, because you do this after a party, you listen to the live reactions and stuff. This one's brilliant because at first when it comes up, you're like, oh, that's very pretty. And hang on, let me just because actually I'm going to put the sound up on this because synchronistically, that's the terrible way of saying it, but you hit the perfect sound for this. There we go. But yeah, it's like, I mean, my video encoder's not going to like this, but yeah, just it already looks beautiful, but then you have the one little, it's just like a tiny little drop of water just creates just the massive ripples, and it's so satisfying.
So yeah, the funny thing about this effect is it's basically the plasma. It's pretty much the same effect, but just with different data. So it's the plasma, but the table was kind of, we had some perspective to it.
Yes, you just bend it down, right?
Yeah, and there's a little bit of other stuff going on. There's some kind of additional ripples and stuff added to it, but it's still like a sum of two sine tables, basically. Whereas, like the big difference is you've got like the radial one kind of fades out, so you've got a repeating sine wave that sort of gradually fades and then loops. But it's still a plasma effect.
Yeah. I love it. So it's just a plasma. I mean, but the thing is that the the color choice just makes it look like it's a repeat of what's happening above it.
Yeah,
but it's not, is it?
I mean, it's definitely some of the same colours. It's it's a gradient sampled from colours from the sky, but it's
like the top half and the bottom half aren't linked, but the colour choices really sell it. Really sell it.
And the other thing, the water droplet, I rotoscoped that from a video. in like 3 colours. So yeah, that was fun.
You basically pixeled that out from like some frames of a video.
Yeah. So yeah, figure out how to convert a YouTube video into a series of PNGs that I could up in A-Sprite and Trace. So yeah, that's fun.
And then we get onto the one that
Mr. Pelicus.
No, this is Pelicus's. Yes, here we go. So I led the creative decision that everyone made on this one, which was butterflies aren't transparent, but it looks better this way. Right.
Apparently some of them are. So
there we go. Oh, excellent. That's fine then. That's fine.
I don't know if they have like different coloured wings like that though. I think we're maybe stretching it a little bit there. So yeah, what to say on this one? So it's another one, a little bit like the leaves, where you've got 2 different layers of texture mapped 2-bit plane textures that are again using sort of palette tricks to overlay over one another.
So you've got 2 because is it each wing is a bit plane, isn't it? Or 2-bit plane, sorry.
2-bit planes, yeah. So yeah, kind of similar to the leaves. But the big thing on this was the animation data, and Pelicus building this tooling to animate it in Unity and export all of the data and play it back on the Amiga. So yeah, that was the hard bit.
Yeah, and that is the tough bit as well, isn't it? Because unless you've got something like a bit of modern tooling to actually fly that stuff about, it'll look janky as hell otherwise, won't it?
Yeah. And just like animating it, like I think we were kind of, a bit last minute trying to get that movement looking convincing, not any of us being animators at that point. So it took a fair bit of sort of studying slow motion video of how butterflies move, and wings go down, body goes up.
Yeah. I think
I mean, the wings are vertical, and
It was impressive that you guys managed to pull that off at the party.
Yeah.
Yeah. With everything else going on, but I think was it the Saturday morning, and I turned up and you were like, "Oh, Pelicus is doing animation data." So one of the coders is doing animation data in Unity. The other coder, were doing pixels, and the graphic artist was drawing for the paint over competition. So,
but we got it done. So yeah. Great work.
There's like, so should I start managing the group?
And then once paint over was done, Steffes came in and rescued us with the flower.
Okay. I mean, I love that as well, because if you haven't seen his paint over, go and check that out. It is absolutely bonkers. I don't know how he managed to conjure that up within, was it 24 hours?
Yeah.
And he must have spent less than that, because he came back and helped you lot out. So
must have slept at some point as well, I imagine.
I imagine so. Yeah. So Ramon's there. Hello. The big boss man. And then when we get to the end of the demo, and that's it actually.
That is it.
That is it. So I think in terms of I didn't really delve too much into like the audio side of it. I do have a write up on that, but I think, to be fair, most of that is fairly common in terms of the Eon write up. It is fairly similar. There are some. I think what we can do actually just to kind of show this off, because I don't want to keep this for too much longer. No, that's completely the wrong button. That's the one. So let's just pull up actually quickly. Let's pull up Koppenheimer. And let's see if we can get an example. Actually, we just do it with the demo, can't we? Let's have a look. Downloads. No, desktop. Yes, final. There, that's what we want. Final. Where's the? Okay, we get the ADF from the WXG load folder, right? Why would you do it any other way?
It should be the same, hopefully.
It should be the same. So actually, you can see here. So to let everyone else know, Gigabates used the double buffer. Let me just put this on mute. The double buffer track loader that I built on stream here, I don't know, a year or so ago. I didn't expect him to use it in production, so we had to go and fix that because it was broken and needed some robustness adding. I think it's about the best way we could put it. Yeah, I think.
Yeah, I mean, it didn't say it was like experimental on the GitHub, so I thought it'd be all good to use.
No, to be fair, I didn't. No.
I mean, we could have easily switched to the non-double buffered one, to be fair, and that's what I would have done if we hadn't, if you hadn't gone in and improved it.
But, no, but I think also I think any saving you get at that point, when we're talking about like the demo basically hammering the crap out of the DMA, or just the CPU more than anything else. Any advantage you get of the DMA doing something whilst you can't is a bonus, right?
Yeah.
So I mean, so in terms of, let's just reset this again. You can actually see this happening here. So you'll see the boot up, right? That's and then we're already. So you see, like you'll get like this flick between. This is basically two MFM buffers that happen here, and you'll see if we just pause this a sec, you'll see these little sections here, these slightly brighter sections. That's a decoded sector. So you'll have you'll see the DMA kind of pummel data into here, MFM data, and then start pummeling data into here, and then you'll see us kind of decoding these sectors here, and then putting those into wherever we need them in RAM. But from also there, we can unpack ZXO data straight from that buffer straight into whatever bit of memory we need it to go into as well, which is kind of handy. So that's that. And then, oh yeah, this is our twin buffer sample bank. So this is the first. Is that it? Up till, oh no, it's quite a lot. That's all sample data. I don't know if you've looked at RAM data as much as I have, but you can always tell when it's a PCM data, because you can see the volume taper off here. I don't know if you've ever seen that. You see kind of where, like, you see these numbers where you get this kind of curve here. See that? That's a sample basically getting quieter and quieter. So you see another one, there. Like, you looked at this stuff in a binary form for long enough, then yeah, it starts to make sense. But if we just let this run for a bit, you will spot eventually. Let me see if we can shrink it up a bit. Okay, about there. You will start seeing it in a bit. So this whole section here is like the lower bank sample memory. Eventually, when this music gets to a certain position, you'll start seeing really subtle, slow changes in here. Oh, there you go. See that? There. And that was it loading a new sample into memory. So, there you go.
I think it was cool that we managed to come up with a much simpler solution than the initial sort of trying to figure out how do we stream all of this off disk and interleave it with the effect data and everything else. That actually, I'll just put it in slow RAM. Ended up working really well.
I think actually that was in terms of the process. Yeah, because it was like, how do we do this? Oh, so we'll have this sample, but we'll have to work out where we need to load that. But what if we change the soundtrack? That means we'll have to change the timeline on the disc, and then actually, but why don't you just give me an extra 50k of slow RAM, and we'll be all right.
Exactly.
So for those who don't know, the way this works is basically. We have two banks of samples, so we have a 200k bank in chip RAM that we can use to play music from, and then we've got 100k of slow RAM, which is our compressed samples. Our compressed samples are 4-bit delta, so they're 100k equals 200k of actual physical listenable sample data. And what happens is when the music needs a new sample into chip RAM, we do all the memory allocation, all that kind of stuff offline, so we don't need to know what is and isn't available. We just know that at this point in time, in this position in memory, we will need that sample. So what happens is on the CIA interrupt, we work all that out offline and calculate all of that, and then the music interrupt has this little program that goes, okay, so about on this frame of the music, we're going to start unpacking 20k of sample data down to this position here, but rather than obviously the CIA interrupt, which is the highest level, like we don't want that blocking. That's a bad thing. It's a very bad thing. We don't want that blocking. So what we do is we basically we know that in 600 music frames time, that sample will need to be uncompressed. So we divide that length of data by the number of frames, and then we just basically unpack about, is it like, I think the most is like 23 bytes of red data per frame. So it just kind of reads about 20 bytes of data, spits out 40 bytes of data on every player tick. So that's why when you look at it in here, you'll see just like it's just a little bit just every now and then.
It's only kind of a couple of scan lines on top of your music player, isn't it? It doesn't really that much. Yeah.
I think we calculated out as it's still even with the unpacker, it's still quicker than the original Player 6.1 replay routine. So which means we're in, right? Because that used to be a de facto standard. So and there were a couple of positions where because of the way the music worked, and there was a whole bunch of samples getting triggered really close together, So there was a section, I think it was during the Roto Zoomer, with the flowers, where actually it was turning into about 7 or 8, or maybe even 9 scan lines of unpacking that was happening.
Yeah.
And I was running the demo going, it's blatantly interfering with the frame rate there. So the trick to get around that is, rather than all of those samples being triggered on pattern 30, 31, 32, you silently trigger them earlier on. You just go into the ProTracker module and go, well, we'll just get that sample, we'll just trigger that on that pattern, but silently, so you can't hear anything, but it then fools the memory allocator into going, oh, well, I need to load this now because you'll need it in 4 patterns time, and then we won't actually play it for another 8 or 10, 16 patterns. So just kind of distribute it out. But yeah. There we go. I think it's time. Let's get some questions because I've completely ignored chat. So if you do have a question, please let us know. Let's move that one there. Let's put that back to there. Where's VLC? Oh, don't tell me I've closed VLC. Hang on. It looks like I might have. Okay. Well, I might put it on. I've just put right up when.
You know what it looks like by now. Yeah.
There we go. So we go there. There we go. That's better. And then we've got your demos in the top right corner. Right up when. So my write up's done. We're just waiting for gigabates. Then I think
note form at the moment. So yeah, getting there.
Getting there. And I think what we'll do is we'll put it all on your blog, so it's all in one place.
Yeah.
But yeah, mine's already 6 pages long. I'm probably going to go and edit that down a little bit. So, couldn't you use the other CIA, which is level 2? Aha. No. He's already using that.
So, yeah, we're using level 2 for our main effect interrupt. Basically, I ripped off what Hannibal does from his write-up. So, yeah, using various interrupt levels for,
abusing interrupt levels, I think is about the best way to put it. Yeah. So the beautiful thing about the Amiga is that you can trigger any interrupt you want pretty much, just by poking the right thing in the right place, right? So, which makes the levels of quite flexible, and it also means things like the interrupt that is usually for the copper and the V blank and the blitter you can then keep free just for the blitter, which is that's the key gain, isn't it? So
yeah, exactly. So level 1's already used for the loader. Level 3 we're using for the blitter interrupt. So yeah, putting the main stuff on level 2 is what makes sense. And then we've got, is it level 5 for the actual frame counter, so one that definitely actually triggers at the top of each frame.
Yeah, and then obviously 6 for the music interrupt, which nothing's allowed to interfere with it, apart from when you turn on Blitter Hog with 5-bit planes, obviously. But
oh yeah, sorry about that.
Yeah. Spacey NZ. Oh, worth waking up early. Oh, we'll put it on YouTube anyway. What was the worst bug? Oh, fucking hell.
Oh god.
Well, you know what it is, don't you?
I mean, there's been a few, but
my personal least favourite was. You know this, Jobbo, anyway. Cause so the GC, so the last section, the butterfly code was written in C++, and was compiled with GCC, and was causing a problem, which I didn't write, but then I had to debug using an action replay and WinUEE to find out why it was broken, which was very strange, because the thing is, if it had been written in assembly, I could just go, oh, I can see where that is, and that matches that. But obviously I'm looking at code that's been generated by a compiler, which doesn't exist anywhere in our code base. So
yeah, I mean, no, you could have debugged that part standalone. Like, you can open it up in VS Code and debug it, but the problem is it was only happening on the actual build, right? It wasn't happening when you run the part standalone.
Yeah. Yeah.
So yeah, that was the issue. It was only in the track mode build where it would blow up.
Yeah, and that's the thing. It's really important to remember when you are making track modes. Nothing is ever the same once it's on the disc. It just never is. It never is. Like no matter, you can try your best. Like, but then, yeah. Like when for some reason, when the operating system's disappeared and all the memory is kind of where it is and it's in a different place and everything else, and then for some reason there's always a perfectly explainable reason as to why it's broken, but you have to find it, which is the worst bit.
Yeah, and the classic one is just having some sort of overflow, but trashing other data somewhere else that only later gets exposed when the next part tries to run, and you've trashed half of its data, that kind of thing.
Dumb question, but do you know Zane Little?
No.
It's finding the bastard first. Yeah. I mean, to be fair though, I like it, I make it sound worse than it is. It feels, for me, it's like reverse engineering. It's like removing copy protection, right? Like when you're looking at a copy protection, you don't have the code there with you anyway, so you have to understand it at a raw assembly level anyway. So it is kind of fun to pull that stuff out and go, hey, it's broken there. Can you fix it? I'm curious to what the process for deciding what to sync is and how much of a collab that is. I'll let you take that one.
Yeah, so what, just in terms of the music sync stuff?
Yeah.
I just kind of did it myself, really. There was lots of kind of really nice hooks in the music to sync stuff to already. So there was a lot of places where it was really obvious, like this is where it should go. But then, of course, like we sent stuff back and forth, and you kind of fed back on maybe try this, maybe try that. But yeah, certainly the kind of first iteration of everything, I just did what made sense, I think.
Yeah. I mean, I got that anyway. It's just like when we got the first iteration of the soundtrack in, and then I got the first cut of the demo back through with the soundtrack in. I was like, okay, all right, no, it's thematically and emotionally it fits, and then like a couple of days later I get another cut, and like you just I can see you just like fitting the puzzle pieces in, and then go, oh, I've not said anything, and he's putting everything exactly where I expected it to be. So,
and like obviously at the kind of high level, the sort of sections of the demos and the overall kind of you knew where the parts were going to be, you knew what the kind of theme was for each of the three sections, so that part was already in place, wasn't it? And it was just the kind of smaller bits and pieces of just
I think the only time where it was it's around the tunnel part. We were taking out, is it 2 or 4 patterns? I can't remember what it was, but I didn't know how it laid out, so I sent you a version of the soundtrack, and then you sent me the demo, and I was like, no, actually, we just kind of needed to do it the other way around, and then I was just watching it, spending like a couple of nights watching the demo, and I was like, no, it's not right, it doesn't fit right, and then I finally got like another cut of the demo with the edited soundtrack, and went, oh, it fits in place now, there we go.
I think it was just like off by like 4 patterns, wasn't it? We just shit.
But I think the first way I laid it down was like the emphasis was on like a change there, but that wasn't the scene change. The scene change was like another 4 patterns later. So I switched it round, and then it made so much more sense. Okay, we're getting trolled here. Zeron, do you think your next prod will be another anim? Oh no, Amiga. Do you think your next prod will be another I think he means Amiga.
Yeah, probably.
Probably.
Yeah.
Amiga demos, or would you just plan to do another platform next? I don't know. I convinced him to work on a Neo Geo demo, and then he built. And then what happened? He built probably the most advanced C2P method on the Neo Geo that exists. So We'll see.
Yeah, I may well get roped into something else, but otherwise,
yeah. So the way it works out is how you coerce your friends into getting involved. Is you do a bunch of the groundwork, and then you give them some documentation and some examples, and then the next thing you know, you made a demo. So that's how that works. Okay, with 177 positions, 4 patterns isn't much. Yeah, I guess that's right, Clayton. Yeah. Did you have some sort of support for syncing each part individually like we did with Vaporous? No, you were just basically out on your own, I think.
yeah. I mean, in terms of what on Vaporous, maybe not.
Hooverphonic said, did you have some sort of support for syncing each part individually? Oh, I see what you mean, like we did for Vaporous. So on Vaporous, we spliced up, because it was ADPCM, you had to splice up the soundtrack. You kind of built that yourself anyway.
Yeah, I did that. Yeah. So I built a little tool for creating various like edits of the mod, starting at different pattern offsets, so you could test individual parts with music. And then each part has its own scripting, which is sort of synced to mainly synced to the music frame, but also sometimes just the kind of V blank count as well. So yeah, a lot like what we did in Vaporous with that part.
So same sort of thing, but just the implementation is different because we're talking ADPCM stream versus Pro Tracker module, aren't we? So
yeah.
Do the return of Mr. Blobby on X68K, X86K. I think you got it around the wrong way there, but there we go. WBCBZ7. I did for my test run on the Sharp X68000. I did a scrolling Mr. Blobby image, which is my de facto standard test image. So
that was the roto zoomer as well, wasn't it?
Yeah, it was. Yeah. Yes, I do remember. Yes, using that for that. Yeah. Let me just see if I haven't missed anything else. How much time did Gigabates put into the demo, and where does he find that time? And can I have some? That's from Jobbo.
I dread to think. No, I don't. Haven't been counting. Probably for the best.
Yeah. I think it's best that neither of us count. We don't count. We just look at the results. No, that's fine. Yeah. Also Francis said, not a question, just bravo and thanks for some motivation that I'm not coming into writing a demo too late in my life. I think, and that's lovely, I think, actually. So yeah, in terms of like seeing someone that is because both, Francis is also, he's a game dev, an ex-game dev, but also a fan of the demo scene and has never made his own demo. But to see someone else that's come from like seeing it from afar and just going, well, fuck it, I'll have a pop at that and see what happens, right?
Yeah, we go definitely.
Yeah. You never know. We could be we'll have Francis on in 4 years' time talking about how he won revision, right? Well, I hope so. Right, if I've missed a question, nope. If I've missed a question, I'll post it again. I will try and answer it. I said thanks for the motivation for me writing code again myself after an AI shit show at work. Leah Rosimer, demo scene is just, it's the happy place. Just write what you want. There's nothing more fun than just pushing a bunch of pixels around the screen, right? And then pushing some values in it with a little bit of maths. It's just lovely, isn't it? Fantastic, guys. Lots of work, great details. Right, I think just make stuff. NE7 with the yes, just make stuff. It doesn't matter if it's bad, it doesn't matter if it's good. As long as you have fun making stuff, that's all that matters. Just do it. Yeah, Helmut, yeah, exactly. Vimster. Right, I think I'm going to before you go, can you give me an Amiga demo that you would consider either a modern classic or a classic? Preferably a one disc.
The pressure's too much. God. 3D Demo 2.
Oh! I mean, that is a fine vintage, sir. 3D
Anyway.
Demo 2. Okay, yeah. 3D. That doesn't show up on Poe at all. Why have I? How? Why does that not show up? 3D Demo. Oh, maybe it's II. There we go.
Numerals, yeah.
II. Oi. There we go. 3D Demo 2.
It's this, isn't it? Sorry.
Oh, I know. I remember trying to download this once, and it was all kinds of broken, actually.
Yeah, maybe not that one then.
No. We're gonna do it. We're gonna download it from Amiga Scene, hopefully. Oh yeah, it's a DMS file. That's gonna work great. Save link as save that to there. Excellent. Right. Hang on. Keep. There we go. Now I can copy that to disk, because I have a Grease Weasel installed in my computer, which is fantastic. Okay, yeah, we'll wrap it up there, Matt. We'll let you get on and chill. What we'll do is we're gonna run the demo one more time, and then we're gonna run 3D Demo 2, and then we're gonna chill out, and everyone can get on with their business. So, anyway. Give everyone in chat, give him a round of applause. Thanks, Gigabates, for spending this time with us.
Thank you for having me on.
There we go. It's been fabulous. Still can't believe I didn't believe you just flipped the bloody screen halfway. Anyway. it's so obvious. Anyway, it's been a great break. Obviously, there'll be a write-up and the rest of it. That's all coming probably the next couple of weeks or whatever. But for now, we will bid our Graham farewell, and what we'll do is we will go to here and we will watch the demo from Real Hardware one more time. If you've got anything you want to say, Graham?
No.
Excellent.
Thanks for having me on. Thanks for your work on the demo, and yeah.
Be excellent to each other and party on, dudes. Right, cheers, mate. And where do I press? What do I press? This one. Here we go.